Tangents are normal. Any line that touches the curve at one point is called tangent. So if that's the curve and you've got a line touching this line is a tangent. Normal is a line which is perpendicular, makes a 90-degree angle here, is the normal. So that's the normal. Now the relationship between the slope of two lines when they are perpendicular to each other is, if the two lines are perpendicular to each other with slope m1, the first one, let's say the slope of m tangent was m1 and the normal slope was m2, and if they're perpendicular, that's a -1. So if you know the slope of one line, so you can find the slope of the other by rearranging the formula. Right? It's as simple as that. So far what we've learned with respect to derivatives is that the derivative is the slope of this tangent. The m1 is the derivative at this point where we are making the tangent. So derivative is the slope of the tangent on a point on the curve, at one single point. Now with that, if suppose we've got a question like, and I'll do one question and then I'll give you one more question yourself to find out. So let's say I've got a curve y equals to x cubed plus half x squared. So let's say I have a curve, a cubic, and I'm asked to find the equation of the tangent at point x equals to 1. So essentially what it means diagrammatically is that you've got a cubic like this. So let's say you've got a cubic like this, right? And let's say this is x equals to 1. This is x, this is y. So at x equals to 1, if I draw a tangent to this curve, which is here, I need to know the equation of this tangent. Tangent is always a straight line, right? So the equation of the tangent will always be in the form y equals to mx plus c if you're used to this one, or y equals to a plus bx, whatever you're familiar with. 99.99% people are familiar with y equals to mx plus c. Right? Now how do I find the equation of this tangent here? So first of all, I need to know the slope. If I know the slope, and if I know the y-intercept, which is this point, then I can find plug all of that in, I find the equation of the tangent. So let's find the slope. What is slope? The derivative, correct? Let's find the derivative at this point on the curve, which means slope of this tangent. So derivative of this will be what? Your dy by dx is 3x squared plus x. Right or wrong? Yes or no?
Yeah.
Now that's the expression for the tangent, the slope. I want to find the slope at this point, x equals to 1. I plug in my, if I say this to be f dash x. So I'll find f dash of 1. That will give me the value of this m, or I can say this is m as well, right? M, f dash x, dy by dx, or rise over run, all are the same thing. Plug in 1, so you get 3 times 1 square plus 1, so you get 4, right? Now I have 4, so I've got the value of m. So now I say my equation is y equals to 4x plus c. Now I need to know c. I have this point here, 1. If I know this point corresponding the whole coordinates of this point, I can plug x and y and can get c. So let me find what is the value of y when x is 1 on the curve, not on the tangent. Please don't make that mistake, okay? I'm trying to get an x and y. So if I plug in x equal, now if this is my f of x, so I'll find, okay, what is f of 1? 1 cube plus half 1 square. And what's that? 1 plus half, which is 3 over 2. Right? Now I know the coordinates of this point here is 1 comma 3 over 2. Let's plug it in here in the equation of the tangent. So I'll say 3 over 2 equals to 4 times 1 plus c. I solve it and I say, okay, 3 over 2 minus 4 is c. So this is times 2 times 2. 8 minus 3 is 5. Negative 5 over 2 is my c. So finally, the equation of the tangent is y equals to 4x minus, that's the equation of the tangent. Does that make sense?
Yeah.
Yeah? Oh, good.
Could you also do y minus y1 equals m bracket x minus x1?
Y minus y1 m times, yeah, you can do that as well. And that's, see, at the end of the day, you still need an y1, right? You still have, I mean, you can't get away with this step here, what we've done. This one, right? Right, then it's your choice whether you go this direction or you go this direction. You can do that, and in that sense, that's a good point. So you say y over 3 over 2 equals to m was what? 4. 4 over x minus 1, and then when you rearrange it, you land at the same spot. Aishka, does that make sense?
Yeah.
Romel? Right? Oh, good, cool. Now, if I extend this, and I'll take a different color so that I can differentiate. There's a lot of scribbling on the board now. If I am asked to find the equation of the normal, this red line, how will I do it? I have the slope of the graph here, the slope of the tangent here, which is m, let's say I call it as m1. So from here, can I not find m2? m2 is negative 1 over m1, and m1 is 4, so I can say, which is 1 over negative 1 over 4. And this normal, Ryan, is also passing through the same point. So now, rather than an m1, you will use an m2, and you plug the same points, but now you're using m2, which is negative 1 over 4, rearrange it, you get the equation of the normal. Or you use this, use m equals to negative 1 over 4, plug those points in, find c, plug it back, you get the equation of the normal. Does that make sense? Yes? Let's do one question, and that'll make more sense. Now I'm giving you the equation y equals to sine x, circular function. You have this as your function, Can you find the equation of the tangent at point x equals to pi by 3? Can you try that, please? And I'll take rest off the board if you want to. Now that tests your circular functions as well.
Can we use our pass?
Yeah, you can, let's see.
Okay.
Alright. That's the function. So what are we asking? We are asking something like this, no? Let's say this is pi by 3, and you draw a tangent here. Ah, no, sorry. That's the equation of the tangent I'm after, correct? This is y equals to sine x. I need to find the equation of this line. So, what's the derivative, Rumel? Half, yes, correct. So, what's the derivative of sine x, Ryan? Sorry, what's the derivative of sine x? Do you know that? Cos x. Okay? Now you plug in x equals to pi by 3. And what is that? If you look into your CAS, is half. Right? Yes or no? Correct? So my y dash or my dy by dx or my slope is a half. Rest is easy now. You also plug in, let's find the y value here. So if you find the function y equal to sine pi by 3, what do you get, Romeo? Root 3 over 2?
Yeah.
That's it. Now you say y minus y1, m is half, x minus, rearrange it, you get the answer.
Could you use a different marker?
Oh, that's very light, is it?
Yeah.
Oh, that's fine, sorry. I'll use it black. Right? And now, if I rearrange it, what do I get? Y equals to, I say x over 2 minus pi over 6 plus root 3 over 2. Yes? Easy? And then you can even find the equation of normals if you want to. Let me now introduce the concept of average rate of change and instantaneous rate of change. I'm taking this off the board.